Hi everybody. This is just an explanation of Ohm's law experiment. So if we were in school, we would have actually done this experiment in the lab. So I'm just going to talk to you about this because we can't actually gather data due to the situation and the scenario we are in. So this is the experiment. So it's actually to find the relationship between the voltage across a wire and the current through it. So Ohm's law is all about what is the connection between the voltage across a wire and when there's a current flowing through the wire, what is the size of the current? So what happens if you change either the current or voltage? Will it have an effect on the other? So this is how we do the experiment in school. So we have a wire, that's the wire, a coil of wire, which we actually immerse in cold water. And the reason we immerse it in cold water is that when a current passes through a wire, the wire will get hot, and that's going to affect its resistance. So we want to keep the temperature of the wire the same. And then we have this, so you have your power pack. It's connected to an ammeter. It's a series circuit actually. The ammeter measures the current through the circuit, and this is a variable resistor or a rheostat. And the reason why we have the variable resistor here is when you move the slider up and down, you can change the size of the current. So what we are doing is for different sized currents, we are measuring the voltage. So every time you move the slider up, you measure the current and you measure the voltage. And then what we do is that we record those readings. So you record the readings on a table like this: voltage and current, voltage measured in volts, current measured in amps. So once you have values for voltage and current, if you plot it on a graph of voltage against current, you end up with a straight line graph like this. What does this tell us? When you have a voltage against current graph and it's a straight line, it tells us that when the current increases, the voltage increases as well. So when both of these increase and it's a straight line going through the origin, we say that voltage is directly proportional to current. And the mathematical way of writing it is V is proportional to I. So this sign is a proportionality sign. It means it's directly proportional to. Whenever you have a proportionality sign, we have what's called the constant of proportionality. That means voltage is equal to some number times the current. Okay? And the constant of proportionality is called the resistance. How do you get that constant of proportionality? That's by drawing the gradient of this graph. I've got to use a ruler to point because I'm holding my phone recording it. I don't have a tripod. Okay. So the gradient of this graph is V divided by I, and no matter where you draw your gradient triangle, because it's a straight line, you'll always get the same gradient. So voltage is proportional to current provided the temperature is constant. How do we know the temperature is constant? We are immersing this coil in water. Usually it's cold water or ice that'll keep the temperature down. Okay, now if you do the same experiment and you replace this with a lamp instead of a wire, you can't put the lamp in water, can you? That's dangerous. So what actually happens, and then we gather the data, just like we did for the other one. But the thing is with the lamp, as current keeps passing through the filament of the lamp, a filament is a thin wire that's in the lamp gets hot. And when it gets hot, its resistance changes. So if you plot a graph of voltage against current for the lamp, you're not going to get a straight line, but you're going to get a curve. And can you see the curve is quite gentle? That means the gradient is quite low here. That means the resistance is low for smaller currents. But as the current increases, see the slope is bigger compared, so steeper there. So the resistance increases as the temperature increases. So this lamp, so the voltage is not directly proportional to current. Okay, so in other words, it does not obey Ohm's law. And because it doesn't obey Ohm's law, we call the lamp a non ohmic conductor. There are also other things like LEDs, diodes that don't obey Ohm's law. Okay, but for now, for you, it's just enough to know there are things, not everything obeys Ohm's law, because if the temperature changes, then Ohm's law does not hold good. All right, and that's the lesson for Ohm's law.